Hello and welcome to the Trade Events Online. Before we begin today's webcast, I would like to introduce you to the functionality of our platform. The webinar will be conducted live on the main screen located below the banner. For better performance, we recommend watching it with the latest version of Google Chrome or Microsoft Edge browsers. Important messages concerning today's event will be communicated to you through the broadcast window. The webinar will be conducted in English. If you prefer to listen to the simultaneous translation, we have today available translations into Russian and Turkish. To listen to the translation, please mute the sound in the broadcast window. The mute button is located at the bottom on the left-hand side of the broadcast screen. To start the translation, click on the play button and select the required volume. If for some reason the player is not active, please click on the Turkish translation red button, which will open the translation player in the new tab. Please use the chat box to send your question to speakers. At the end of the presentation, we'll have a Q&A session where a speaker will answer the questions. On the right-hand side, you will see the list of the viewers who are currently watching the broadcast with you. To communicate with the speaker after today's broadcast, please complete the contact form located in the personal profile alongside the information about the company. At the end of the webinar, we will invite you to join the virtual meeting room where you will be able to interact with the presenter, the IT members of staff, and other viewers. We hope this helps and wish you a productive participation in Trade Events Online webinar. Добрый день! Добро пожаловать на площадку Trade Events Online. Перед тем, как мы начнем сегодняшний вебинар, давайте познакомимся с техническими возможностями нашей платформы. Они позволят вам слушать трансляцию в синхронном переводе, задавать вопросы выступающему, а также по завершению вебинара встретиться с ним и с другими зрителями. Трансляция будет показываться на основном окне, расположенном под баннером мероприятия. Мы рекомендуем использовать последние версии Microsoft Edge или Google Chrome. Непосредственно под окном трансляции расположена бегущая строка. Через нее мы будем транслировать сообщения, касающиеся сегодняшнего мероприятия. Вебинар будет проводиться на английском языке. Под бегущей строкой расположен баннер синхронного перевода. Пожалуйста, отключите звук на видеоплеере в окне трансляции, чтобы он не мешал вам слушать перевод. Чтобы выбрать язык, нажмите на нужный флажок и затем нажмите на кнопку Play, которая запустит перевод. Вы можете приглушить или усилить звук перевода с помощью функции регулирования громкости плеера. Если по какой-то причине плеер на вашем экране не активен, нажмите на красную кнопку «Слушать». В следующей закладке откроется отдельное окно, в котором вы сможете запустить перевод. Пожалуйста, направляйте вопросы докладчику через окно чата, расположенное под кнопкой синхронного перевода. В завершении презентации мы предложим выступающему ответить на ваши вопросы. В окне рядом с чатом расположен список активных зрителей, находящихся в этот момент на сайте. Информация докладчика расположена под окном чата. Чтобы связаться с ним, заполните контактную форму в профиле. Рядом с профилем расположена закладка с информацией о компании и видеоматериалы. По окончанию мероприятия мы пригласим вас пройти в виртуальную комнату. В ней вы сможете встретиться с выступающим в формате экран к экрану или лицом к лицу, чтобы обменяться с ним интересующими вашими вопросами, ну и также пообщаться с другими участниками этого вебинара. Желаю вам приятного просмотра и продуктивного общения на площадке Trade Events.
Dear ladies and gentlemen, good morning and good afternoon. Thank you very much for joining our session today. My name is Olga and I represent the UK Department for International Trade based in Kazakhstan. When you were registering for this event, you may have noticed that we are arranging a series of various events for the mining industry dedicated to various subjects. And today's session subject is geological exploration and in particular geophysical logging equipment and software. A UK company who will be presenting to us today is Robertson Geologging. It has an extensive experience in the industry, over 40 years experience, and it designs, manufactures and supplies geophysical logging equipment and software for such industries as oil and gas, mining and minerals, renewable energy, water and environmental sectors. And now I would like to introduce our speaker to you today. It is Gavin Ronalds, who is responsible for international cooperation development in Robertson Geo. Gavin has an extensive experience of the industry. He has a geologist background and he spent over 22 years working as a logger and geologist. 3 years ago, he joined the Robertson Geo team and he is responsible for international business development. And before I hand over to Gavin, I would like to quickly outline the program for today. So very shortly, Gavin will start his presentation to you, which will be followed by Q&A session. And then we will have a networking opportunity session. In order for you to be able to ask your questions to Gavin, I kindly ask you to use the comments bar, which you can see under the main broadcast screen. As for the networking session, I will share the joining instructions with you a bit later. Enjoy the session today, and now over to you, Gavin. Thank you.
Thank you, Olga. Good morning, all. Good afternoon and good morning, depending on where you're listening in to us from. Thank you for joining us this morning. As Olga said, I'm Gavin Rowlands, Business Development Manager for Robertson Geo, based in Wales. In the time we've got this morning, I'm not going to go into the detail of how every geophysical logging tool works, but really this is an introduction to the types of tools that can be used for mining exploration and ore body approval assessment. Firstly, like many of you over the last few months, I've been working from home since March, and I'm actually speaking to you today from the island of Anglesey in North Wales. Which is about 25 miles from our base in Diganwy. Anglesey itself has a very interesting mining heritage. You'll see the geological map on the left there of the island and the yellow arrow at the location of what was once the largest copper mine in the world at its peak in around 1785 and the turn of the century and turn of the 19th century. So the photo on the right, you see the very large open cast pit that was hand dug with hand tools and gunpowder. Many shafts and tunnels off the main cast, and how things have changed. Some of the ancient sketches of the mine show some very precarious lifting equipment up and down the cast. But I thought it was an interesting connection, the copper, many of you working on copper assets as we speak. The copper from Anglesey was exported all over the world and in many cases found its way onto the bottom of copper plates on the bottom of ships. So it had widespread applications. So that's Anglesey. This is the first webinar I've presented. I'm normally used to presenting to a live audience, so please bear with me. It's a little bit odd not being able to see my audience. As Olga mentioned, Robertson Geo is a geophysical logging company specifically for borehole logging, and I'd like to give you a very brief overview of the company and a little bit of its history in a couple of slides. So we specifically develop and manufacture our own geophysical logging equipment, and we work across multiple sectors, notably mining, geotechnical site investigation, groundwater and environmental, renewables, doing a lot of work with wind turbine site investigation. We're active in the oil and gas sector, and we also have a service division that goes out on site to conduct site investigation, be that underground in a mine, could be a new railway for a geotechnical investigation. So we're very much a multiple sector. And I think the advantage of us having a service division is that our field engineers daily use the equipment that we manufacture. So we're able to continually evolve the equipment based on feedback from our engineers. So Robertson Geo, as I said, is located in North Wales in the UK. It was established in 1979 and was formerly Robertson Geologging. The company was rebranded a couple of years ago to the branding that you see now, Robertson Geo, to more reflect our multi-sector approach. The company is majority owned by the Oil Corporation in Japan, which has over 1,500 staff worldwide. Oyo is essentially an earth science organization specializing a great deal in earthquake detection and earthquake monitoring from their Oyo headquarters in Tokyo. And they have a number of sister companies that they own that are also involved in geophysical ground and subsurface investigation. So the company designs and manufactures geophysical and petrophysical logging technology. It's all designed at our base in North Wales, and we have a research and development facility along with our own borehole on site. We also develop the software for data acquisition. When the data is transmitted to surface, the data has to be acquired, processed, and interpreted, and we develop that software to be able to issue a final report to the client in the format that he requires. As I mentioned, we sell equipment in 6 market segments that you saw on the previous slide. And because we've been active for 40 years, the equipment's actually been sold and been active in over 150 countries worldwide. So we have a very well-established international background. Our logging services team, although primarily work in the UK, will travel to any part of the world. And for example, currently we have 2 operations going on offshore of the Northeast USA on a wind turbine site investigation. We've worked on mines in Africa, bridges in Venezuela, wind turbine fields in Taiwan. So, have logging tool will travel. We have a technical support line and replacement service 24/7, so that we can provide continuous technical support from very experienced geophysical and technical engineers who can conduct troubleshooting remotely. Around the world, we have a global agent network. Quite often, these are geophysical service companies or companies involved in the provision of some sort of site service to their customers. And through them, we conduct customer training and on-site commissioning. When we ship out equipment from our Welsh base, very often our engineers will travel on site to conduct training and commission the tools so that the client can get up and running very quickly. Obviously, with the current travel restrictions, some of that is having to be done virtually. We've increased our digital content so we're able to guide our clients through that online. We also have an extended research and development program into new tools, new methods of conducting geophysical logging, and there will be some announcements later this year and next year on some new tools that are coming out. So that's just a little bit of background on the company for those of you who don't know us. A few images. Sorry. Sorry, bear with me, missed a slide. There we go. Okay, so I mentioned we have a borehole on site. So on the left-hand image, you'll see tools being prepared to go into the borehole, which is around 100 meters deep. And every tool that leaves our base is run down the borehole for calibration and conformance performance certification. The other pictures, you'll see one of our electronic technicians assembling a probe. That the bottom middle picture is our electronics workshop. Top right is one of our engineers conducting a calibration on a logging probe before it leaves our base. And the bottom right is a high pressure, high temperature test chamber where we can test tools to destruction when we're developing new bodies or wanting to test issues with tools. So we have full capability on site for testing, calibration, R&D, and manufacturing. Just a quick glimpse at some of the range of logging tools we have. So these are various suites of. Top left is a GeoKey oil field logging set. Top right is a selection of our mineral tools. Bottom left, those strange looking yellow canisters are containers for transporting radioactive sources. Obviously, there's strict legislation around moving radioactive sources internationally, and they have to travel in these containers. Right, why logging? Why do we conduct geophysical borehole logging? It's logging's a very established and very cost-effective method for exploration and ore body evaluation, providing valuable mine safety information at the beginning and throughout the project. Logging reduces the need to core every single borehole. Typically, on an exploration program or an appraisal program, only 1 in 10 boreholes need to be cored for quality assurance purposes. So logging saves valuable time by reducing the need for expensive coring, having a rig on site, having personnel on site, manning the rig, and time-consuming coring programs. And quite often with coring, depending on your subsurface conditions, you may end up with a core that looks like the image on the right, where we have a severely fractured section of core, which is basically crumbled and consolidated. And in that case, it would be extremely difficult to detect any fractures, any structure, any bedding planes in the core. So where you have very poor core recovery, logging provides vital in situ data, as I say, especially in highly fractured zones. The other advantage of logging, particularly with the new generation of televiewers, is for core orientation. And televiewers are able to provide orientated data even in highly fractured zones. So you can, where you have a combination of core and image data or logging data, this provides an excellent picture of what's going on, and the logging data will fill in on where you have zones of poor fracturing. One of the other advantages of logging that the sampling interval can be down to as small as 1 centimeter. So this provides superior vertical resolution on the subsurface geology compared to other techniques which may be conducted from surface. Deviation surveys can also provide information on the ore body, and looking at the difference between true vertical depth and measured depth can give an indication of the depth, the true depth and direction of the ore body, which could be vastly different from the drill depth. In situ geotechnical information can provide data on the actual stresses in the ore body, the direction and magnitude of the fractures. A host of imaging tools that we'll come on to shortly provides accurate data on the geological structure, fracture analysis, bedding planes, dip and direction. And the image on the right, you'll see that's an optical televiewer being prepared to be placed into a borehole. And other tools that we use, geophysical tools that we use in exploration, can provide information on the hydrogeology, groundwater conditions that may exist around or within the ore body, and the degree of overburden, which is obviously critical to the economics of the asset. So we come to look at mining applications, and we would start with exploration logging. So this would be early stage evaluation of an ore asset, new resources, extensions to existing mines, and can be used in coal mineral exploration, coal bed methane, and defining the extent and true location of an ore body. Once the asset has been discovered and initially explored, you would move to production logging, which is much more based on a more detailed grid, probably at a higher frequency, and conducting a detailed mapping of the discovered resource. From production logging, the next phase we would see would be geotechnical logging, especially in deep mines, or we have complex geology with heavily fractured formations, borehole stress, and also we would get an indication of slope stability information from some of the combination of tools that I'll come on to. Hydrogeological investigations, obviously mine dewatering planning, water within mines, where does the ore body sit in relation to aquifers? This can all be defined by some of the geophysical logging tools that we use. And cavity surveys, one of the things we find in the UK, there are many old coal mines and shafts around the country that now find themselves under areas of residential development or light industrial development. And it's critical to map these old mine workings for grouting and remedial purposes, and in some cases solution mining. So there are tools that we can use to determine the location and the size of these cavities. So first, I'd like to talk to you about imaging tools. And by imaging tools, we mean tools that give you a picture, either optically or acoustically, of the borehole. The image you see there on the right, again, is an optical televiewer being placed into a borehole with a centralizer just above the OPTV window, which allows the tool to be, the centralizer allows the tool to be placed centrally in the hole for optimum measurements. The example log on the right, so what an image tool gives you is an unwrapped 360-degree view of the borehole. So the black and white image you see on the right shows degrees of fractures, bedding planes have been picked out, dip tadpoles have been represented in the right-hand column. So this is the type of image that can be produced optically in a dry borehole or in a clear water borehole. So there are two main types of televiewer currently in use, and obviously this technology has moved on dramatically in the last 10 years or so. And you know, as a geologist, to get a picture of downhole conditions and the downhole formations is invaluable. And you know, to see quite clearly the thickness of the beds, the degree of fracturing, some of the smaller features. You know, you can see in that bottom left picture, some infilled veins showing through there. So as we said, we get a 360-degree orientated borehole image. This is used for fracture identification and orientation. We can identify bedding dip and direction. Lithology identification, you will quite clearly see differences in lithology, looking for tops of formations, tops of ore bodies, cavities, washouts in the borehole. So this can be used for stratigraphic studies and core orientation. So the image on the right of the probe, you'll see that is a typical optical televiewer with the optical window at the very bottom. Tool is around 2 meters long and is connected to a data cable that transmits live data to the surface. And we can generate the type of image on the right. The log is a composite log showing an optical image through quite a long section with some geological features picked out and dip meter tadpoles analyzed and displayed. So that is the optical televiewer. And the second type of imaging tool is the acoustic televiewer. So the acoustic televiewer we would use where borehole fluid conditions are, shall we say, suboptimal for use of an optical televiewer. Optical televiewers tend to require fairly clear conditions downhole. So if we're operating in a mud-filled borehole or a borehole that where the sediment in the fluid won't settle out, we will use an acoustic televiewer, which again produces a 360-degree view of the unwrapped borehole, and again can be used for fracture identification, orientation, bedding dip direction, lithology identification, and you'll see some of these features in the images on the right. Local stress studies can be conducted to see the direction of stress from the fracture patterns, and core orientation, so the log can be set alongside your core and can be correlated by depth and by lithology. So the image on the right, you'll see some green features picked out there. These will be picked out by the engineer and by the software, and to highlight the key features in terms of stress or fractures on that image. Okay. I just bear with me here. Okay, so another imaging tool that we have, it can be used for especially deep mine applications, is a borehole video camera. RGO has recently developed a new camera that will actually be released next month, called RGOI. So this camera is a optical live data feed to surface, full color, with a 3,000 meter capability. So you can see on the left, there's some examples of images from downhole, showing the quality of some of the images it can produce where you have a damaged borehole. The bottom right in particular, you can see that's a washed out borehole. It's possible to see water influxes using the camera, and it's a tool. It's a very useful tool for lithology identification, dewatering studies to see where flow is coming in and the degree of flow, contamination studies where there may be pollutants coming into the borehole, mine shaft inspection. In fact, on the picture on the left, you can see our logging vehicle over a mine shaft. That, in fact, is the new mine at Anglesey, Paris Mountain, that we saw on the first couple of slides. So the camera with 3,000 meter capability is a very good way of inspecting the condition of the borehole. You may want to go down and have a look for inflows, damage to casing. What's the condition? Is the hole highly overlyzed? And generally, contamination studies. We mentioned another tool that for larger borehole shafts and caverns is the sonar caliper. So the sonar caliper sends out an acoustic signal 360 degrees around the shaft that you want to measure. So in a fluid fill situation. And this is a very useful tool for the application I mentioned earlier, for example, old coal workings or old mine workings, where the degree and the geometry and the volume of the shaft needs to be calculated so that concrete can be poured or to resettle the subsurface cavern. The pictures in the center of the slide, you'll see these are examples of the output, and you can quite clearly see the geometry and the size of the cavern that's been measured. So this is essentially a marine sonar which sends a ping from the transmitter, and again produces a live signal to surface through our cabling and winch system. And you can see a couple of our engineers there loading the probe into a shaft on a test run in North Wales. Let's look a little more at exploration tools that can be used for logging. Obviously, there's a wide range of geophysical logging tools, and really which tool you select depends on the type of geophysical measurement you want, and also the type of mineralogy or the ore body that you're looking at or trying to define. Probably one of the tools of choice is a formation density tool. So this can be used to detect density and porosity, the lithology of the ore body, bed thickness, boundary location, and in coal assets, coal ash and moisture content. Engineering wise, from the combination of formation density, sonic and neutron tools, we can obtain rock strength and elasticity parameters that's in conjunction with a sonic log. And that can also help detect weathered or fractured zones. So this is one of the tools that requires a nuclear source, radioactive source. And if you look at the image of the probe on the right, you can see the arm where the word caliper. So that arm is in contact with the borehole wall and can be deployed or retracted from surface. An example of the formation log produced by the formation density on the right. So the red curve that you see is the gamma, and the blue, green, and black curves are those produced by the formation density tool and provide very good correlation. And I believe in this instance, this was through a sequence of coal beds. So you can see very clearly the difference in density of the coal beds being picked out. So formation density, probably one of the tools of choice for mining applications, and very popular in conjunction with, as I said, the imaging tools we mentioned earlier, and the sonic and neutron tools. So this is the dual neutron. Again, this can be used for lithology identification, location of the aquifer and aquitard. Aquitard being the less permeable layers of formation that may exist above or below the aquifer. The neutron tool can be used to identify fractures in coals and for correlation between open and cased hole logs. And also very extremely useful for strata correlation between where you have a number of wells with you may have a depth offset and you need to correlate. The neutron tool provides a very detailed capability to do this. Again, this is about a 2 meter long tool, plugs into a 4-core cable head and transmits live data to surface. The full waveform triple sonic. So this is probably the third tool that could be used in combination with formation density and the dual neutron to give fracture and permeability indications, the strength of the rock and Young's modulus, again in conjunction with the other two tools, lithology identification, porosity, and the correction of seismic velocity. So where a seismic survey has been conducted at surface, this tool can be used to correlate with that seismic data. And again, a typical log on the right-hand side showing the sonic output received at surface. Again, about a 2.5 meter tool, and you can see it a small A tripod being used on site in the left-hand image. I believe this was on a dam in China, I think. Okay, hope you're all still with us. I haven't fallen asleep yet. I'll try and move this along. Other very useful tool for spectral gamma is spectral gamma 4, which basically has a detection capability for potassium, thorium, and uranium. So this is useful in applications where you need to type or the shale or clay, which can be used for correlation in very complex interbedded situations, mineral detection. We've had applications where the tool's been used for radioactive waste pollution measurement in nuclear power stations, for example. And again, it can be used to determine the lithology. So you see a rather large detector at the base of that tool, produces the three curves of potassium, thorium, and uranium on the right-hand side. The induced polarization tool, used in particular applications where we require an indication of mineralization, particularly of sulfides. We have a lot of minerals, a lot of ores that express themselves as sulfides in the ore body. So induced polarization can be used, for example, to differentiate between hematite and magnetite in an iron ore situation. It can also be used in the water evaluation for permeability studies. How easily or how poorly is water able to move through the formation? Magnetic susceptibility. So this is a particular tool for use in detecting uranium, where the log shows a negative correlation with uraniferous compounds. The magnetic susceptibility tool is highly sensitive to iron and shows large contrasts in its oxidation state. And you can see an indication in the log on the right-hand side how it's picked out that type of sensitivity. Frequent occurrence of iron with other redox sensitive minerals provides a valuable indicator of the presence of other minerals. So often used in conjunction with other like formation density tool, but used in very specific circumstances for the ores that are mentioned there. So the other very critical thing to know when you're doing borehole logging and trying to ascertain the whereabouts of an ore body and its definition are deviation tools. So one of the logging tools that can be used is a borehole verticality tool. So this gives an indication of the degree of deviation from the vertical of the borehole and can provide surveying and deviation checks. You know, quite often you think of boreholes as straight cylindrical features, but more often than not, if you take a look at the third image along from the left, which shows a track of a deviated corkscrewing borehole, which is quite often more in reality that, you know, to the types of boreholes that are produced, then they're not always nice, smooth, cylindrical features that are dead vertical. So borehole verticality is critical in determining deviation and from that TVD in relation to measured depth. And related to deviation measurement is a gyro and gyromagnetometer, which we can use to conduct verticality measurements within steel casing or in the presence of magnetic ores where a borehole verticality tool wouldn't be able to be used. So magnetic ore bodies and steel casing application for the gyro. And again, you can see some of the images on the right hand side that are produced. But the plots in the bottom, again, very illuminating on the actual trajectory and the 3D geometry of the borehole. It's very easy for you look at that first image on the left there. That very easy in a hard formation for a borehole to be thrown off the vertical track by steep bedding planes or fractures to end up with a deviated borehole in that placement. So we've got my counter's not moving properly here. Okay, let's move on a little bit to quality assurance and the importance of, firstly, having calibrated tools. So all the tools that leave our factory are calibrated with a certificate of conformity and calibration, having been run down the borehole that I mentioned earlier. So having calibrated tools is critical in assessing borehole, assets, the degree of mineralization, the actual location of the ore body, the depth of the ore body. And this is critical information for ore reserve publication with the international standards that are quoted there. So the Robertson Geo tools and ISO 9001 procedures are followed very strictly for every tool that leaves the facility. And you can be assured that once you have that calibration, the tool is generating correct ore body and mineral information on site. The use of uncalibrated tools would not comply with some of those standards that are stated there. So, as I mentioned, the company is also licensed to handle, test, and ship nuclear tools which are needed for things like formation density. So radioactive sources can be shipped safely to international locations. And all the equipment supplied with conformance tests and quality control documentation. And these are some examples of the certificates that are issued. So one is issued for every tool, dated by our test engineer, certified with an example of the log produced by that tool for a certificate of conformity. We've actually written a technical article on calibration, why calibration is important. There is a Russian version of this article on our website, which you are free to download. I believe that is in the download tab and GeoInfo on our website. So one of the points that we often stress when it comes to borehole logging, the data that you obtain from your borehole really is highly dependent on the drilling conditions that were in place at the time the hole was drilled. So good drilling practice is critical to maximizing data from boreholes. Most geophysical probe theory, logging probe theory, is based on the hole being a smooth cylinder, vertical, and with chord rotary holes producing the best types of boreholes. As you can see, the image on the right, that's an example of a borehole we were in recently. Quite clearly, that is not a smooth cylinder. It's got ovalization, it's got breakouts, it's got fractures. The actual volume of the borehole is going to be much greater than the theory would predict. Small diameter boreholes generally provide best data. The larger the diameter of the borehole, the greater the chance of breakout, collapse of the borehole, greater ovalization, and generally movement of the whole drill string within the borehole. So there's obviously a compromise between how small you can go for cores, suitable cores for core analysis, and for logging tools. Our logging tools are typically 42 millimeter diameter, with some exceptions where you have radioactive sources making the body of the tool larger. So it's always worth discussing when you're planning a borehole program, discussing with your coring and logging teams what would be the optimum size to give you the best data from that borehole. Borehole stability is obviously critical. If we can't get the logging tools down, you're not going to get to bottom. You'll have an unlogged section of hole, and quite often what we have to do, and we're seeing this increasingly, is run the logging tools through the drilling rods and the drill bit, and retract the drilling rod section by section to try and reduce the amount of collapsed hole. Obviously, there are very tight tolerances on running logging tools through drilling rods. Logging through casing in boreholes generally gives qualitative data only. Obviously, we see plastic casing, PVC casing, and steel casing, and depending on the thickness and the quality of the casing job, can affect the quality of the data that comes through. You know, if the cement job is good, there's a chance of getting better data. If there's a lot of washout in the cement behind the casing, this is going to weaken the value of the data. Drilling mud can affect some probes, depending on the density of the mud, the composition. As we've said, for example, with an OPTV, optical televiewer, this needs a fairly clear or settled fluid to be able to obtain data. We have produced a probe application guide, which shows borehole design and casing effects data from different probes. So you can select, I think I have an example of that here. So this is available if as a A3 wall chart. Again, you can download it off our website, or if you require a full-size version for your wall, we can send this out to you. So it's a little hard to see the text in this small format, but it's basically looking at the log measurement and the type of tool that is needed and the type of casing that you can get a measurement through. So this helps in pre-planning of boreholes. And the little table on the right shows you the probe response in open and cased boreholes, whether that's a valid application or not. So feel free to load that down. That's quite a useful chart. Obviously, when we sell equipment or we're on site, we want the client to be able to be up and running very quickly. So typically, we can get a good field hand, a geophysicist with field experience, up and running in 3 days with a borehole logging system on site. We typically send out a commissioning engineer and conduct a combination of classroom and hands-on training, with including troubleshooting, you know, how to obtain the best data, things to look for when the data's coming back, recommended logging speeds, what to do if you get stuck, all sorts of issues which are covered in the training. Yeah, my little cursor has got stuck here somewhere up there. So. Okay. Yep, that is actually the last slide in the before. So as I mentioned, take a look at our website, robertson-geo.com. We have produced a lot of an increasing amount of Russian language literature. So there are some technical articles on there. Our Geo Unlock newsletter in Russian language, which can be downloaded again from the Geo Info section. So feel free to download those if you're interested. I will give an open invitation for any of you who are in Wales would like to come and visit us. This is the view from our office on a good day in summer, which it's not today. We've got some wonderful castles up here. That's an image of Conway Castle, just across the river to us, from around 1284, I believe. So if you're interested in history and would like to combine that with a visit to our base, you'd be very welcome. Thank you very much for listening, and hopefully I haven't gone on too long. Happy to take any questions, or if you want to contact me after the presentation. I would also like to point out that we have a regional representative based in Atirau, Mr. Serik Tlubayev, and he can be contacted locally if you need local support or assistance. Thank you very much, all. Happy to take some questions if there are any.
Thank you very much, Gavin. It was very interesting. Of course, I'm not a geologist, and at times it was very complicated, but I really like the last photo of the riverside and the castles. And yes, I hope one day we will be able to visit. Thanks again for your presentation. And dear participants, now it's a good time for you to ask your questions. As I mentioned in the beginning of the session, please use the comments bar under the broadcast screen. And we have a couple of questions now. A first question from Gulis Orazbaeva. Could you please inform us about the price of your equipment and software, please? Thank you.
Yeah, we would be happy to provide a commercial quotation. We tend to customize our quotations depending on what you need. We have a wide range of tools, so it depends on things like the depth of your borehole, which affects what type of winch you require. Do you require, which types of tools, logging tools do you require specifically for your mineral asset? So we'll provide you a customized quotation depending on your circumstances, and I'm happy to do that.
Thank you. The second question, how Robertson Geo probes stand out from other companies' offers?
Okay, so Robertson, as I mentioned, been in existence for 40 years. The company was really the pioneer of slim holes, so that's narrow bore logging, in the tools in which we specialize. So a couple of things. We are the OEM, original equipment manufacturer. We develop and research all the equipment ourselves. As I mentioned, calibration and conformance are critical. So we issue certification for all tools that leave. We have ISO. We're the only slim hole logging company that has ISO 9001 quality management system. And I think as I mentioned somewhere in the presentation, the fact that we are a service company as well. Our engineers are out in the field today using these very tools. We get feedback from them on the design of the tool, the response of the tool. Does the winch need modifying? For example, we do a lot of offshore work, and our service engineers had some feedback about our standard winch. So we made a lot of modifications, particularly using things like stainless steel. Using winches offshore, we're subject to saltwater corrosion. So we made a lot of amendments and adaptations to the winch based on feedback from our engineers. And obviously, when we sell that winch to a customer, that knowledge and experience is passed on. So I think those are some of the key things that make us stand out.
Absolutely, these are the key thing to work, with one company who offer turnkey solution, and you cover such a wide range of operations, which is very handy for your customers. We have one more question, please.
Yeah.
Are there any limits to your products in terms of certain conditions, such as weather, temperature, etc.?
Okay. In temperature, I'll give you an example. We have a client who works in Antarctica, and Greenland, Everest, and in the Alps. That particular client is investigating doing ice studies for climate change evaluation. I think he mentioned he was working down to minus 28 degrees centigrade with our winches and tools on one of the glaciers down in Antarctica. So at the top end, at the low end, I don't think we have any difficulties. At the top end, we typically the temperature. So okay, first of all, the depth limitation on the majority of tools is around 2,000 meters. There are some special circumstances for particular tools a little less than that. The camera that I mentioned we've developed is capable to 3,000 meters, and we will be producing next year. I mentioned we're releasing some new product, so that will be capable of capability to 125 degrees downhole conditions, and up to 3,000 meters depth. Borehole fluid conditions, as I mentioned, depends on the tools that you're using. Whether you have clear fluids or thick muds, we can provide advice on the best tools to use in those conditions. We very much have a very strong technical team that have been with us. To be fair, the majority of them been with us for many years, so they know our tools inside out. They know the response that they get from different hull conditions, so we can provide advice on that.
Okay, that's impressive. That's great. Thank you. And a question from Tugrul Tash. What are the maximum downhole limits? Limits pressure and temperature. I think you've covered temperature.
Yes, I think yes. Yeah,
pressure.
yeah, and pressure. For example, just looking at the televiewer, we have a 10 MPa version or a 20 MPa version, depending on conditions.
Okay, thank you. A question from Yerbol to Subekov. Do the calibrated logging tools give an adequate data to determine the rock mass classification systems?
Yeah, yes, they do. That's one of the uses for the calibration, which is used as the basis. And we strongly recommend that where tools require a calibrator, some tools have what we call a field calibrator. So it'll take the calibration from our borehole. The tools need to be regularly recalibrated in the field. Occasionally that's not possible, and we do have some clients that return tools to us maybe once a year for recalibration in the borehole, because the tools can drift over time with use, and depending on things like the life of the radioactive source in a formation density tool, for example, the calibration will change over time.
Okay, thank you. A question from Iberkson Mess. First of all, Iberbek is thanking you for your very successful and very interesting presentation. And
Thank
he
you.
would like to ask, if you have any work on chrome mine?
Chrome mines, off the top of my head, I don't recall any recently. I would have to check our database with our service logging team. I know we've worked on things, for example, uranium mines, iron mines, gold mines, and underground, overground shafts, adits. But chrome, I'd have to check specifically on that one.
Okay, thank you. One more question from Tugrul Tash. Could you provide statistical data on fishing operations of your tools? He means how easy it is to fish the tools, please.
Right. Okay. Yeah. Well, hopefully, hopefully fishing operations are rare. We don't want to get stuck, but we do provide a fishing head. So it's like an overshot head that will attach to the top of the probe, so it can be recovered. It can be run over the wire line as an overshot. Can be latched onto the top of the probe and recovered through wire line. To be honest, we've had very, very few stuck tool situations. And I know in the oil field sector, stuck pipe, stuck logging tool, stuck cable is a real issue. But I think with the right procedures, and an important aspect is having a look at if you suspect you've got a borehole that is like some of those images, washed out, deviated, fractured, collapsed, it's worth inspecting the hole first with a cheap tool like a 3-arm caliper, which will give you an idea of the geometry, or with a borehole camera before putting an expensive logging tool down. So that obviously you can't always anticipate the condition of the borehole. It could collapse while you're down there. But we do provide advice, and as I say, a fishing head that will act as an overshot for recovery.
Okay, thank you. And one more question from Tugrul Bey.
Mhm.
Do you have any LWD tools? If not, what is the maximum angle we can select while on tools? Have any shuttle-like or through tubing drill pipe applications?
Okay, there's quite a lot of quite a lot of questions in there. Okay, so very simply, currently we don't have LWD, logging while drilling tools. The angle again depends on the tools, but I think it's typically if we start getting beyond 45 degrees, a lot of the measurements become unstable. It becomes very difficult to centralize the tools for those tools that need to be in the center of the hole and not on the low side of the hole. Shuttle, we have had some discussions with a third-party company that does provide shuttle conveyance for logging tools. So we haven't actually provided it yet, but that capability is available if needed. And was there another aspect to that question?
Have any shuttle-like
LWD, the
Yes.
angle of the hole, and shuttle capability.
and drill pipe applications?
Drill pipe. Okay. As I mentioned, in some instances, and we had to do this in a gold mine in Ireland, the hole was we were running televiewers in 400 meter, 500 meter holes, and the hole was collapsing before we could get the logging data back. So we actually had to run the logging tools through the drill rods and through the drill bit, and then log a 15 to 20 meter section, retract the drill rods, and then do it section by section. And of course, the hole was collapsing behind each time, but they did manage to log the data. Obviously, the tolerance between the tool and the ID of the drilling rod is very tight. So you need to be very sure of your drift of your drilling rods, because they're not going to be sitting vertically, and there may be some drag, which really reduces that tolerance. I think in that particular case in the gold mine, it was something like 2 or 3 mil, which is not very much to run a logging tool inside a drill rod, but it was done by our engineers. So yeah, we can do through pipe logging, but it requires a very good understanding of the dimensions of the logging tool, and the drill rods, drill pipe.
Okay, thank you. I don't see any new questions.
Okay.
And I guess now this is the time to thank the audience for participation in the webinar. Please follow the link for the virtual meeting room where you will be able to ask further questions and continue discussion with the presenter. To continue listening to simultaneous translation of the meeting, please keep the translation banner open in the broadcast page of your browser. So see you shortly in the virtual networking room. Thank you.
Olga, do I have to change screens?
You can unmute your microphone here in this window, and if you have a look at the comments bar here, you will see a link which you will need to follow to enter the virtual room. On your left-hand side, you will see the conversations, sorry.
Okay.
Have you found it? Conversations tab?
Yes. There's the link. Okay,
Yes.
I see it now.
Yes,
Okay.
is a link. Unmute yourself here, please, and then follow the link. And switch on your microphone in the new tab window where you will enter now, basically.